I think that would fit in. Next Thursday. Quiz on 8.1. Just like. For PL. In class. List the factors and answer a word problem like that. Okay. Now, everybody, I hope you got the well, you got the notes, but you also saw that I had to change the office hours. Was that on the Tuesday? For some reason, I didn't realize that this never happened before. It took away my home. I never have had somebody, another class use this classroom after I'm, when my classes are over. So I'm always able to do an office hour after class. So I have a class that comes in on Tuesdays and Thursdays, and I can't have it. Just like I have a class that comes in at 11 o'clock on Monday, Wednesday, and Friday, so I can't do an office hour after their class. But then again, I have an office hour every Monday, Friday morning. Well, we also have this support class before 10 be anyway. It's just have to speak up and have a question. So fix it on the front page. Right. Number 2. Let's. You need a degree in mathematics, so you can teach high school and intermediate school math. It is a little misleading, because what are you teaching high school, intermediate? Teaching algebra, arithmetic, geometry. Depending how far you've gone in math, maybe some calculus and trig, those kinds of things. But in order to do that, you need a degree in mathematics. So what do you do when you're getting a degree in mathematics? You're doing algebra, but not algebra. You're doing the theories behind that. You're doing the theories behind counting numbers. You're doing theory, you're doing history of mathematics. You're doing a whole course on word problems, problem solving. You're doing a whole course on set theory, which will never come up when teaching high school, right? Intermediate. But you got to make the brain work. Probability and statistics. Okay. When I decided to go for my master's, I had to go talk to a professor at Fresno State, and I had to go over my transcripts with him. And he was looking at my transcripts, and he said, "Wow, you got a B in this class and this class. You must not work very hard." And I'm going, let's see, I was coaching freshman JV and assistant varsity boys basketball, working 35 to 40 hours a week, so I went to school full time. Yeah. Yes, I didn't work very hard. He didn't, I mean, he doesn't know it. If I said those things, so he probably wouldn't care. All he saw was I had a B in 2 classes. He said I would have to retake those classes. When does President's Day off, something like that? Well, in the middle of the day when I'm teaching high school. I don't actually have it. So I went to President Pacific stuff, which is a private school, which is more expensive, but everybody who goes there to get a master's is going to get a grant that pays for half. You just have to write a quick essay, turn it in, when you get this grant. At least that's what it was back in 1991. And it was the best education I ever received. And it's not because we never had a test. In all the classes that I took, we did not take one single test. I take that back. There was one class we took 2 tests in, but it wasn't that bad at all. All you had to do was be there. You had to be, no absences or try to be no absences. Night classes and homework. And I actually enjoyed doing all that homework. Something to take pride in. I should have taken my transcript over to that professor at President State and said, look, I have an A in every single one of these stuff. And he probably said, well, that's President Pacific. Stop. But it was the best education. It was practical stuff that I actually used in my classroom from that point. We go for a degree. And please don't take this like I'm bragging about getting A's or anything. I never got A's in math when I was taking my degree at Federal State. I got 1 A in my geometry class, and that was it. Everything else was a B, and I think I got 1 C, but everything else was a B. I ain't that bright. All the other professors around here, they're so much more smart than me. I understand what it's like to not get it. So I ain't that bright. So just trying to give you some context and something I'm trying to relate with. That's it. Playing the mind, right? Simple. If A, B, and C are natural numbers, so natural numbers start with what? 1. Naturally, we start with the number 1, 2, 3, 4, 5. And A is equal to B times C. So some number A is equal to the product of B and C. Then we say A is a multiple of those 2 numbers, B and C. A is the multiple. So 10 is a multiple of 2 and 5. Ten is equal to 2 times 5. So 10 is the multiple. 48 is equal to 4 times 12. So 48 is the multiple. B and C are the factors or the divisors of the A. B and C, these 2 are the divisors of the A. So 4 and 12 are the factors of 48. 2 and 5 are the factors of the 10. They're the gazintas. 2 and 5 is into 10. 2 is into 10, 5 is into 10. 4 is into 12, 48, 12 is into 48. Factors go into the number, multiples are bigger than the 2 multiplied together. They are a product of 2 other numbers. That gets confused by students all the time. Example, factor of 10 are 1, 2, 5, and 10. So the factor, what goes into 10? 1, 2, 5, and 10 go to 10. The multiples of 10. What does 10 go into? 10 goes into 10, 20, 30, 40, 50. So what are the multiples versus what are the factors? In some cases, we may consider zero as a multiple. We tend to not. And the reason why we can eliminate zero from the very start is right here in the definition, we use the word natural numbers. Natural numbers don't start with zero, so zero is not part of the group. But under special circumstances, zero is invited to the party. Some cases. Okay. In the context of a word call, we might say there are 28 students in this house Art 1 class. 28. What are all the different ways that this how you can arrange the desks in rows and columns so that each of her students has a desk and none left over? So if we have 28 students, how many ways can we arrange the desks in rows and columns so that each of her students has a desk and none left? So would we be looking for multiples of 28 or factors of 28? So we want numbers that are bigger than 28? Because the first multiple of 28 is 28, and then you got 56. Right. Because what we're going to want to know is how many ways can we make. So let's just say there are 5 people. We can make one row of 5. Or we can do, well, that's it. Because if we only have 5 people, so desk, 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 desk. But then if we go desk, desk, we have a leftover. We want nice even rows and columns. So if I do 2 and a 3, that won't work either. I can't do a 1 and a 4 because that's leftover. So the only way I can do it for 5 desks would be a row of 5. But that's the only thing that goes into 5, is a 1 and a 5. So I can either do this, it was 5, or I could do this. One row with 5 desks in it, or one column with 5 desks. But if it's 28, what number is going to 28? 1, 2, what else? 4, 7, and 14, and 28. So you could do a 1 by 28. So you have 28 desks like this, which is probably not the best way to do it. Or you can do 2 times 14. So that would be 2 by 14. So you have 2 columns, and each one has 14 desks in it. Or you can do a 4 by 7. So you have 4 columns with 7 desks in it. That's three, that's another one. And you can do a 7x4. Is the 7x4 different than the 4x7? Yeah, it would be different because it looks different. The arrangement would be a different setup in the classroom. So a 7x4. So you would have 1, 2, 3, 4, 5, 6, 7 across this way. And then you would have 4 in each. And then you would have 14 by 2. So you'd have 14 across, and there would be 2. Yeah. And then you would have 14 all with 1, or sorry, 28. 28 by 1. So what are all the different ways? Well, we wouldn't draw, you could draw the pictures, but 1 by 28, 2 by 14, 4 by 7, 7 by 4, 14 by 2, and 28 by 1. Pros and cons. I'll scroll up in a minute, but I'm going to kind of try to read that into put all the stuff I wrote. Blake is putting up a fence. If the fence is made up of wood planks, and each plank is 2 feet wide, what are the lengths of fencing that you can put up? Blake's putting up a fence. If the fence is made of wood planks and each plank is 2 feet wide, what are the lengths of fencing that you can put up? Now, let's make sure that is it that straightforward. Basically, multiples of 2. You can put up 1 plank. So you have a 2 foot wide fence. Put up 2 planks, you have 4 feet wide. You put up 3 planks, you get 6 feet wide. You put up 4 planks, that 8 foot wide fence. You put 5 planks, that 10 foot wide fence. So basically, you're only going to get multiples of 2 foot wide plank. Fence. Going to be an even number. That's all. So you know where my head went is when I went to overthinking. What do you want from me? Oh, you just want how many possible lengths of fence you can make in 2 feet wide? 2, 4, 6, 8, 10, 12. Even numbers. But I had to stop and think, is that all they're asking? Yeah, that's all they're asking. And if you ever run into a question like that during a test, just come up and ask. We find all the factors of a number. One way is to divide the number by all the counting numbers smaller than it and see which ones divide the number evenly without a remainder to be more efficient and keep track of the quotients. Organize the factors in a table. So a good scientifically proven attempt would be something called, so a real scientific name, guess and check. So for the number 40, start with 1. 1 times 40. Go to 2. 2 times 1. 3, well, 3 doesn't work. 4 times 10. Then go to the next number. 5 times 8. 6 doesn't go to 40 even. 7 doesn't go to 40 even. And then when you get to 8, you're going to get 8 times 5, which is the same as 5 times 8. So when you get to a repeat, you stop, it doesn't count. So all of the factors of 40 in order: 1, 2, 4, 5, and then 8, and then 10, and then 20, and then 40. Those are all the factors of 40. Those are all the numbers that divide into 40 units. Organize a table. You start with 1, and you just start going down the list. Don't try to skip anything. It's really not going to take you a long time. It won't. If you're organized, it'll go a lot quicker than you will expect. $352. So 1 times 352. We know it's even, so 2 is going to work. And that's going to be 2 times 176. And it's going to double check. And then 3. So that's going to be 3 and 5, 8. 8 plus 2 is 10. 3 does not go into 352. So 3 is not going to work. 4 goes into 52, so 4 is going to work. So 4 goes into 35, that's going to be 80 times. We're going to get 32 left over. 4 goes into 32 another 80 times, so it's 4 times 88. 5 doesn't end in 5, so 5 doesn't work. 6, since 3 didn't work, but 2 did, because 3 didn't work, 6 is not going to work. 7, well, if 7's going to work, then 7 should work on the 4 or the 8. 7's not going into either of those, so 7's not going to go. 8. I see that 8 can go into 88, so I bet 8's going to be able to go into that. So 352 divided by 8. So it goes into that 4 times. We get 32. 52 minus 32, that's 352 minus 32, that's another 30, that's 44. If 3 didn't work, 9's not going to work, 10's not going to work, 11. You see how 44 is right here? 11 goes into 44, so I can take an 11 out of that. I have 8 times 44, so that's 8 times 4, or 11 times 4. So that's 88 times 4. Or in this case, my bad. I want to do 11. Come here, 11. 11, and 8 times 4, 32. And in order to use a 12, 12 has to have a divisibility of a 3. So since 3 doesn't work, 12 doesn't work. 13, no. 14, no. 15, no. 16. 16 will go into that. 11 times 32 is 11 times 2 times 16. 22 times 16. Seventeen's prime, it's not going to work. 18 needs a 9, which would need a 3, so 18 is not going to work. 19's a no, 20's a no. 21 needs a 7, nope. And then you get to 22, which is just going to repeat this. So the factors of 352. One, two, 4, 8. 22, 32, 4, 8, 176, 358. But you cannot just randomly go all over the place and pick random numbers. Start with 1, go to 2, go to 3, go to 4. As you see, when I got to 8 and 44, and I'm, 9 doesn't work, 10 doesn't work, and I'm thinking about 11, I saw that this has an 11 in it. So instead of having to do all the work and do a long division, divide by 11, I just used factor. I took that last answer, 8 times 44. I need to know what 11 is going to be. So here's my 8. And then I have 4 times 11. So 11 times 32 is what that factorization. That's not nice. As you can see from the previous example, it may be inefficient to check each counting number. Let's review. In section 8.3, we will improve on this method by learning about divisibility tests. So that's just a little teaser. A, B, and C are counting numbers. What numbers are counting? When they hit, say, counting numbers, we're focusing on what kind? What's that? The natural numbers, 1, 2, 3, 4, 5. And both A and B are multiples of C. See, all of this information, we want to take it apart and make sure we realize what we're telling you. A and B are multiples of C. So give me a number, just something I can think of, so I can think about it concretely. Give me a number between 1 and 10 that I can use for C. 8. So if C is an 8, A and B are multiples of 8. So if C is equal to 8, then A could be a what? As a multiple of 8. See, that's where we gotta get 8 or 16 or Those are the multiples of 8. B could be another 8, 16, 24, 32. Multiples mean they're bigger than the original. Okay. So the question is, if A and B are both multiples of C, is A plus B multiple? If so, give a general answer, a proof. I'll show you how far you can go back. And then if it's not true, give a counterexample. In other words, show an example that makes it false. So let's see if we just use one of our numbers that we picked, if it works. So pick one of those numbers out of the A set. 16. And then pick another number out of the B set. The 8. So the question would be this. Is 16 plus 8 a multiple of C, which is 8? So it's 16 plus 8. 24. So is 8 plus B is 24 a multiple of 8? Yeah. All right. That's an example of just going, okay, the answer is yes. But maybe it only works for 16 and 8. C or you know what I mean? It only works for those special numbers. So you can try another number, try 32 and 16, and that maybe it only works for those numbers. So you have to try every single possible combination of numbers that we don't have time in our life, or in the universe life. So when it says give a general proof, I'm going to ask this of you. I'm going to show you how it's done now. This is where mathematics becomes the pure truth, because it's the science that is always not just accepted as true, but must be proven as true to be said to be true. So A is a multiple of C. So that means A is equal to some number N times C. 5 times C, 2 times C, it's some number times the C. That's what a multiple means. So when we had this 16 and C was an 8, 16 is equal to a multiple 2 times the 8. Okay. B is a multiple. So B is equal to some number, let's call this M times C. So the question is A plus B a multiple of C? So if I go A plus B, Well, since A is a multiple of C, it's this. And so I'm gonna switch colors. And all I'm doing is a little substitution. N times C. And then plus B is a multiple of C. So that's some number M times C. Okay, I'm going to ask you to do something that you might have not done for a long time called factoring. Greatest common factor, reversing some distribution. When you have A times B plus C, you can distribute and get A times B plus A times C. Or you can go the other direction. You have a common factor of A, so you can factor A out and get B plus C. Factoring, distribution, these two have a common factor of C. I'm going to factor C out of both. It's C times N plus M. So U plus V, when I add these two numbers together, C times N plus M. Which means A plus B is a multiple C times some number. C times whatever N plus M is. It's a multiple of C. So the question is A plus B also a multiple of C? C? Yes? No? We. Now, instead of just saying, oh, it works if we pick the 24 and the 16. Now it works because we've shown that it works for any possible number you could possibly imagine. So we've shown it works for variables. And when a little kid comes up and says, well, I don't believe you, I'm saying, yeah. This means it works for everything. Practice problem. Let's take a look at that data. Find all the factors of 2016. The answer is right there. Look at all those factors of 2016. See you next week. Yeah. And we'll get back to absolutely homeless. I wish I gotta really mess with this over the weekend because I don't like how I can't change much with it, but if I can, I will. I don't like how this layout looks. I mean, for some reason they put this huge blocking thing until we get started. And it doesn't allow you to print the assignment. Which, and I don't have an option in the setup to make that happen. Yeah. I gotta probably go to their help. So hit to get started with it. Build the praise. One, two, three. 5, 6, 10, and 30 are blank of 3 of 30. So bring those down. Are they factors or are they multiples? What do you think? They are factors because they're smaller and they go into 30. So click on that and check the answer and they tell us well done. And if we want to try another problem, trying on initial practice, we'll do that. Otherwise, go to next. Fill in the blank with the word factor or multiple. So it's not here. You don't type it in. You scroll down. It's a select question, just like before. 6 is a what? Factor or multiple 36. Factor because it goes into. Multiples are bigger. So factor again. Now, let's say you don't remember. Help me solve it. Give an example. Or get more help. Ask the publisher, show me the textbook. What's that? So yeah, let me get it wrong. Multiple. All right, got it wrong. That's incorrect. The answer multiple, the correct answer is a factor because 6 times 6 is 30. It goes into it. So now it's wrong. So if I hit save. What do you see? Yeah. Over here we have one that has a check mark on it for we got it correct, or right here, the one with the red X incorrect. So we know what we have to fix. What is that? Go back to the one. Go back to the assignments. Zoom. Right there, it shows us we still have to fix this one. So you go back into it. Question number 2. And what I need to do is I need to ask for a similar question. So 6 is a factor or even. Which of the following is a correct statement of m times n equals p? See, and this is where, and it could just be because of the size of the setting I have in my computer, but I can't get the question up here with the answers, because as soon as I scroll up, it's gone. If I do that, it's no good. No good for this whole thing. So m times p. M times n equals p. P is a multiple of m. Is p a multiple of m? Yeah. M times another number is equal to this number p. That Looks good. P is a factor of M. Does P go into M? Is P a factor of M? No. Remember, over here, M times N, these two multiply equal P. So that means these two are the factors of P, and P is a multiple of M and N. P is both a multiple and factor of M. A multiple and factor both is a multiple of M and it goes into M. Well, over here we said it's not a factor at all. So here it can't be a factor either. So that's a no and no. P divides into M. So if I divide here and divide here, would this go into M even? No. So the only answer is A. So this is what I printed out when I set it up last semester. The rest of the questions for 8.1. List all the factors of 33. List all the factors of 29. List the factors of 70. Determine whether the first number is a factor of the second. The factors of 33. 1 times 33. 2, no. 3 times 11. Does 4 go into 33? Does 4 go into 33? No. Because 2 didn't go. If 2 didn't go, 4 can't. How about 5? These are both prime. So am I going to find any other factors? No. The next one would be 11 times 3. So that's it. Use a comma to separate answers with me. So when I type this in, I'm going to go 1, 3, 11, 33. Now, probably going to give me a different question on the homework itself. Thank you. Okay, very good. Oh. Answer box. No, I don't need a toolkit. Toolbar. I'm just going to list the answers. Let me give you, how about 2.5 seconds? What are the factors of 11? 1 and 11. Okay. Do I have to put them in order? Can I put 11 and 1? I'm gonna see. I'm gonna check. Because sometimes the Pearson will accept it. So I want to see if they don't, if they care whether or not it's in order. But why wouldn't you do it on a test from you? If I had to go through the whole list of numbers, like, what if that question that you saw there where it had like 45 answers, and you decide you're just going to scramble it all together out and well, you have all of them. All you're doing is making it tougher for me to see if you have the right answer. Don't do that. Put them in order. But I'm gonna see if Pearson here. 11, 1. I don't care. Back over 90, back to. Eight, yes or no? Is the first number a factor of the second? Is 8 going to 22? No. This is the second number a factor of the first? Does 56 go into 56? That's a yes. Any number is always a factor of itself. Assume that 9. $35 and 35. So we're going to put yes. Okay, take a look at. Kind of get a look at this. 17, 18, 19. 17, I know it looks forbidding or foreboding. The first United States census was taken after the revolution. Answering these questions here. Choose one correct answer, choose one correct one. Or 25 players on a professional baseball team, 15 on a professional basketball team. Answer this question. Or the 2 essential medical workers, blah, blah, blah. Answer this question. Pick one of those two. So 17, 18, or 19. Actually, a little bit bigger. And I'm doing this when the way I personally prefer to teach is about showing example. So you have something to refer to when you're going home. Because you're going to get a different question anyway. So 17 gives you information about the census, and you got to answer 2 multiple choice questions. Or 18, word problem, or this 19 word. I'll do one of those 3. 18 is baseball season. I think so. Baseball. The last. $25 players on a professional baseball team, 15 players on a professional basketball team. What is the smallest number of athletes that can be split evenly into either baseball team or basketball team? It's not a great worded problem. What is the smallest number of athletes that can be split evenly into either baseball teams or basketball teams? So when would we have enough athletes where we could make baseball teams and basketball teams? So if we had 10 players, 10 athletes, 10 people will show up, would we have enough to make a baseball team and a basketball team? Only 10 people. No, I couldn't make either one. If we had 25, we could make a baseball team. We could make a basketball team. Could we make both? They can't play both sports. If we had 25, we would make a team, two teams. Nope. What if we had 30? Done. What's that? So 30 would be 2 times 15, but would we have, so we can make 15, so 15 of that 30 could make a baseball team. Or sorry, could make a basketball team. Now you have 15 players left over. You can make another basketball team. Well, what about the baseball? Because we want to make the smallest number of athletes can be split evenly into either baseball teams or basketball teams. Okay. Smallest number of athletes that can be split evenly into either baseball team or basketball. So if you have 15 people, you get one basketball. If you get 25 people, you get one baseball. You get 30, you get 2 basketball teams. You get 45, you get 3 basketball teams. You get 50, you get 2 baseball teams. All its number. This doesn't have to show we got to do a problem. I click on text book. Maybe it'll take me to an example. But this is where you bring up access to the text. I think it would take us to this topic. And then building up, we're taking this for this topic. And let's just see on the one. That's gonna go. Might be stuff. Not a 7. So let's figure out, let's see. How about? What's the first number that 25 and 15 go to? 75. 75, I can make 3 baseball teams, or I could make 5 basketball. Can either make baseball or basketball. 30, I can't make any baseball teams at all. 45 can't make any baseball teams at all. If I choose 50, I can make 2 baseball teams, but no basketball teams at all. So, what's that? They say 15. 15 on basketball. Baseball 25. So baseball is 25. Basketball is 15. So baseball, you have 25, or you can have 50, or 75, or 100 players, or 125, and so on. For basketball, you would need a 15, you would need a 30, you need a 45, you need a 60, you need a 75. 75 is the first common factor or multiple. Common multiple between 15 and 25. Where you can make either baseball or basketball teams with nobody left over. That's the smallest number. That's the first number that 15 and 25 are going to be. The least common multiple. 75 cross my finger. Excellent. Just sometimes wonder who writing the question because I don't know the word. Sound like was forming. Oh, but please, okay, I'll stop complaining. One more time. I don't like food. It doesn't form it. There was a time this guy be that old man shaking the fist at the butt. They'll give me a porch swing, so you off with the man to feel good on the lawn. Good thing I got a dog. No. Even and odd and the divisibility test for 2. What does it mean for a counting number to be even? How do you know something is even? Divisible by 2. Divisible by 2. So that means divisibility by 2. In this section, we'll study the definition of even and odd and several equivalent definitions, as well as how we can tell if the number is even or odd and why it works. Okay. Quick questions. 0. Is 0 positive or negative? Or neither? Well, a little louder. I got classic rock music and 11 in my head. Really bad. Neither. Neither. Anybody else? Positive, negative, neither. Neither, neither. You think? Positive. If you put 0 on a number line, what do you think? If you say it's positive, why would it be positive? It's like right there on the board, right there on the fence, right there. Why would it belong to the positive? And if you say it's negative, then who's to say that it's negative? So what is probably the answer? It's a neither. It's neither positive nor negative. You know, when you study chemistry, you have electrons, protons, and neutrons. Electrons are what charge? Negative. Protons are positive, neutrons are neutral. Zero is that neutral. Zero charge. Okay, so it's neither. But here's the other question. Is zero even or odd? So the definition of even, it's divisible by 2. That's how you test for even. Divisible by 2. So if I go 0 and divide by 2, and 0 divided by 2, or 0 and I divide by 2, what's the answer? 0. So is it divisible by 2? Yeah. Since 0 is divisible by 2, the answer 0 is even. 0 is even. It doesn't have a sign, not positive or negative, but it is even. So just a quick look at this last concept. A natural number is even if it's divisible by 2. The following all the same, they're equivalent definitions. A counting number is even if there's no remainder when you divide by 2. No remainder when you divide by 2. A counting number is even if it can be factored into 2 times another counting number. So you can factor out the 2 times something else. It's an even number. A counting number is even if you can divide that number of objects into 2 equal groups and not left over. Okay, talk about that on Tuesday. How do we know or how can we demonstrate the concept of even to a child? Well, make groups of 2. Everybody partner up. If something is left out, that's an odd. If everybody can partner up, that's an even set of numbers. When you have something left over, it's not even a top. Okay? You start on the homework. Only 2 people are into the Pearson right now, so we can rescue them. And 1, 2, 3. So, Savannah, I got you. Everybody else is here. Have a good weekend. Stay out of trouble. Get going on the homework. We'll see you on Tuesday.